Boys, girls, how are we? Got my coffee, phone's on silent. I've actually got audio this time. Yesterday, Arvo, I tried to do a live stream and I screwed my settings up so it was silent and no one told me. Good on yous. So now we're down the drain. I went through the intricacies of Vox amps, their problems, this particular model, its issues, demonstrated the fault, all that real professional stuff, you know, down the drain. Now, I watch a couple of YouTube channels, and some of these guys have been doing it for 10 years, like since YouTube started, and every now and then they still do that, so it happens. Your software updates, the settings go back to default, you lose all your customization, stuff like that. Computers are involved, it's never going to be predictable, eh? Anyway, enough excuses. On with the show, now you can hear me. How does it sound? Does it sound alright? Let me know. Type in. So yeah, in summary, this amp here was running too hot. If we want to cut down to it. When I say running too hot, the output tubes were biased too hot. Now this particular model is pretty cool actually. It's got some cool bells and whistles for a Vox. It's got your usual output transformer impedance switch between 16 and 8 ohms total. It's got output bias switching, so it's cathode biased amp, and you can change between two levels of two bias points. Now here it just tells you the cathode resistor value. So it says 50 and 82. So 82 is the cooler bias, so here it calls it warm, and then 50 ohms is hot. What it's actually got is an 82 ohm, which is that big bad boy there. It's always running through that, and when you flick it over to 50 ohms, it parallels that little one with it, which is 150 ohm 5 watt. That's 10 watt. And then that changes when you parallel two resistors together. A little formula you do to figure out the total resistance. In series, you just add them up. In parallel, it's like you add up the inverse. So that when you parallel them together, it reduces the resistance, thereby increasing the current flow for the output tubes and make them run hotter. Voxes are known for pushing the tubes real hard and running them over spec, like EL84s is the output tube. They're supposed to have maximum plate voltages 300, I think. Some Voxes I've seen, it's been up to like 400. So if you don't keep an eye on the bias, things can run away pretty quick and burn tubes and cause damage. Unfortunately, these things sound really good biased hot, so they've got a reputation as they just kick the tubes ass. So that's how things are. And unfortunately, they sound really good right before they set themselves on fire. So Vox keep making them that way. Anyway, back to here. So yeah, you got your two bias point switch. So this one was running right on edge on the warm bias. So it was running at like 109% or something of safe. So 100% is you shouldn't exceed the wattage of that tube. It's on the data sheet, the 100% safe maximum dissipation they call it. So for a fixed bias amp, you sit around 60-70%, about 2/3, because the bias jumps up and down in a fixed bias amp with load, whereas in a cathode bias, it's fixed bias. Anyway, with a cathode bias amp, it barely changes regardless of load, so you can push it right to the edge. So about 95 is sort of the go-to bias point, 95% of the data sheet maximum safe dissipation level. So in the warm bias, this amp was running around 109%, which is, it's a bit warm, but as long as the screens don't melt, you should be alright. But when you clicked it over to hot, it was running like 130%. that's asking for trouble. You're gonna if you don't damage something, you're gonna rip through valves super quick. You're gonna be changing them every year, and they're not expensive, but they're not cheap either. They're like I don't know, they would work out at about $80 to match quad. So yeah, moving on, we've got smoothing, two smoothing levels. So that's the first capacitor that the rectifier sees when it comes out of the voltage sees when it comes out of the rectifier. Sorry, it's early. I've only had one sip of my coffee. So you can switch between 22 microfarad, which is pretty minimal filtering. They call that vintage, or click it over to 44, which is they call modern on the switch here. So a bit more filtering for a bit stiffer bottom end, probably a little bit quicker response, a little bit less compression when you're cranking it right up. And click it over to vintage if you want that sort of spongy vintage sound. So yeah, there's a lot of cool stuff in this amp. It's pretty versatile, but the thing with amps like this is you'll find that people will buy them and then they'll set it to what they like and they'll just leave it there. Like, oh, don't touch that. I don't know what it does, but it sounds good. So it'd be good for a studio amp where you want to have a few different tones, but for a live amp, guys generally buy what they want and just either get them customized, voice to their requirements, what they want, which you can bring amps here and I'll voice them to what you want if you want something changed. Obviously don't bring me like I don't know, an MG series Marshall and say make it sound like an 800, because I'll say, well, no. But yeah, they're versatile amps, these ones. Good for studio, but you'll find that in practice you probably won't use the bells and whistles as much as you think you would. So there's a few things I'm doing. When I did the video yesterday, I was halfway through getting stuck in, and the missus got back from netball and I went and cooked dinner and realised that I didn't have any audio on the video, so I deleted it. So you've lost the measurement of the bias. I'm not going to reconnect stuff and redo it, just take my word for it, eh? You'll see it on the next one. Yeah, so I'm going to disconnect some stuff, flip this board over. I'm going to change that resistor from an 82 ohm to 100 ohm, just to cool the bias down a little bit. We're not going to get below 100%, but we'll make it a bit less brutal, and hopefully it won't burn up valves as quick. Get some nice leaded solder. Now the construction of this amp is pretty cool. It's got the valve amps mounted the valves mounted directly to the chassis and just hardwired, so you don't have the usual valves cooking the PCB issue. It makes it nice and easy to service. You can leave the valves in. I like the way they've done it actually. They've got the plate connections, screen connections. Well, actually that's the screen there. They've got the plate connections and the heaters just wired and tucked away over in the corner, because you're not generally going to disconnect them to do service. And then the stuff that is connected to the board is very minimal, and you can just disconnect it off the turret, which is pretty cool. Turrets are good. They're like little rivets for electrical components, electronic components. So they rivet to the board. You pin over the back edge of it, and they sort of clamp to the board once you've riveted them. So good mechanical connection, and easy to disconnect components for service. This thing always gets blocked. I'm just going to get another one, clean it later. Alrighty. I've got to switch over to my big boy soldering iron up there, desoldering station. It's a Pace MBT or R80, I think. It's a real good one. I want to reorganise my bench. Thinking about getting a digital oscilloscope because over here might be hard to see, but let's take that off the mount. Over here takes up a lot of bench space. That's sort of my stack. That's the oscilloscope. That's the power supply. That's the hot air station, and then I've got the soldering and desoldering station on top of that. And that takes up like over a square foot. So I wouldn't mind getting all that stuff off the bench and have a bit more bench space. Because stuff, when you've got a few amps happening at once, stuff gets pretty cramped. You just sort of end up piling stuff up around you and you feel like a hoarder. Oh, there we go. All the crap come out the end of the tip there. Lead oxide and burnt flux. How do you like the cam in cam look? I'm just using my webcam. I just use a little laptop out here, Lenovo thingy, so you can see my stupid face. How are you still blocked? Tip's alright. Must be the filter. I think it was the filter. Try again, shall we? We shall. That's better. Where were we? Oh yeah. Giggity giggity. The beauty of the last video screwing up, I guess, is don't have any barking dogs in the background today, which is nice. Who don't have dogs, seriously? They're like little prisoners that you just hang on to for some reason. Alright, so on the schematic, I'll give you a quick look. Where are we? Yep, that's working sweet. So on the schematic, the screen resistors here, R4, R6, that's the output valves there. But anyone that's seen schematics before knows what they're looking at. R10 and R8, they're 100 ohm, half watt, according to this. But what's actually on the what's actually on the amp here. They're 470, so they look stock. They were wrapped in the same way as the other resistor. However, the other resistor here, the control grid stopper, according to the schematic, is supposed to be R3, R5, R7 and R9, which is 1.5K. But they're 3.3K. So I don't know if these are field revisions or if someone's been in here before and changed it. I mean, it could be another revision schematic too, not even a field revision. They could be, like when I say field revision, it means that it had an issue, it was in warranty, it went to a service center guy's gone, yeah, this is the fix, this will get you sort of reliable again. They implement it and then send it back to the customer. A factory revision is when it hasn't made it out the factory door yet, but they're already deviating off their schematic. Now, for a company as long a history as Vox, it's a bit sad that that would still be happening, but it does. People take over and they don't understand, like when a company gets bought out, people take over, they don't understand either the history, or they don't care, or they get another engineer in that thinks he's hot shit. He might be. And he changes stuff without really understanding, well, it's badly designed, but that's that sound or whatever. Like, so yeah, stuff on the factory floor does get modified. There's different revisions of schematics. Often when you've got an amp like this, there might be, well, look right here. So I'll zoom in so you can see right below the logo there, ISS. Now that means not International Space Station, although it means that too, but not in this case. That's issue. So that's got a blocked out thing, then it's got 2. So that shows you that this is an issue 2 board. So that will link up with the schematic. The schematic probably says on it what issue it is as well, so you know to look at the right schematic with the right board. But often for a particular model of amp, the info on the internet might be pretty thin on the ground, so you got to work with whatever you've got, and you sort of just cop it on the chin that there'll be differences. And you know, it's a valve amp, whatever. If there's nothing dramatically wrong, it'll probably work. But you know, there's small changes, revisions. Things like power ratings of resistors have been upped if they went a bit too cheap in the first place. Thought they might get away with it, and then a few blew up, so they revise it and upgrade things, move stuff around. I just had that Bugera amp you might have seen on the page if you're a follower, which you bloody better be. It had an issue that was from the factory. I don't know if maybe they revised that in a later edition, because it was a pretty simple fix once I got to the bottom of it, but it was quite obvious, but it wasn't at first. I thought something was wrong with the amp. Well, there was, but it came from the factory that way, so yeah, that's fun. Anyway, enough talking shit. Let's unsolder some more stuff. But yeah, if you're into the Vox thing, this amp's not bad. If you find one second hand, I'll grab it. You can have less problems with this amp than an actual vintage Vox. That people buy vintage amps, pay $5 for the friggin' thing, you know. Oh, all original. Yeah, that means it needs a comprehensive service. Probably going to cost you another $1,200. Speaker's probably shot. Reverb tank's probably fucked. But if you buy something from the 90s, 2000s, you might be in the clear. It might actually work. without being restored. Of course, once you restore the other things, they're great too, but just bear in mind that extra cost. I'm not doing this shit for free for you. I do like it, but not that much. Just cleaning up the old solder off the tube sockets. Not bad sockets. They're just those generic ceramic ones, not Belton or anything, but can't see a brand name on them, but they look pretty good quality. The crappy Chinese ones, you can see the molds are really shit, and there's bits of ceramic missing on the corners, and they've been rolled around in a box and bits chipped off them. These actually look pretty good quality, so quite happy to leave them in. So I'm upgrading the screen resistors to 1K from 470 ohm, and on the stock circuit 100 ohm, which would absolutely cook them. So that's 4 of them. I think they're 2-watt resistors, metal film, fusible. If anything goes wrong, they don't just sit there and conduct all day. They'll open up like a fuse, which is good. And I'm going to change that resistor, as I mentioned, to 100 ohm. So I've got to actually remove the board to do that. So I'm not going to connect any of these grid stoppers, screen grid stoppers, until we've done that. Let's remove the board. God, I look even pastier than normal on this screen. That's bad. That's what happens when you spend all your time in the garage, you get pasty. Now, of course, as usual, I've checked that everything's discharged, you know. Don't just jump in with a screwdriver in your amp at home. Yeah, I like this amp. I reckon it's one of the Voxes I'd probably suggest. I haven't gotten too deep into the preamp circuitry because they weren't interested in voicing changes. They just wanted to know why the thing isn't working. That was because of a shorter tube. But yeah, apparently there are some differences between this and the traditional Vox circuits. They're not quite bang on tone wise. I'm gonna have to disconnect some more stuff here, I think. Flip that over. Looks like it's just these 4 holding me back. Get rid of the lead-free solder. You can see that little symbol there. Got a PB with a cross through it. That's the symbol for lead, indicating that all the solder is lead-free, which I think is required for export to Europe these days. Which sucks a bit because lead-free solder is shit. It's getting better, but it's still shit. A bit of leaded solder. Sweet as. Just feeling a bit freer. Gotcha. There's another one holding on there somewhere. The green one. Just trying to figure out how the hell I got this thing in here. It's a bit tight. That's the main earth connection, so we can just unscrew that one. That's good. We put a nylock nut back on there when we put it back together. That was just a normal nut with a bit of Loctite, but not super keen on Loctite. I've seen it fail. It's a bit freer, but there's still something holding on. The black one. Where do you go? You solder to the fuse holder. I'm not undoing that. That'd be annoying. Should be able to get in there. Get rid of the excess solder. She's blocked again. Fuck me dead. Lead-free solder does that. Seems to a lot more. Struggling. See, it barely makes it inside a little boot, and it, because lead-free solder's got a higher melting point, it solidifies when it's barely made it through the little hole. So it says it's a lead-free iron, but I'll just jack up the temperature a bit more, so it's at least molten when it goes through the little hole. Turn up the 3. gotten solid even in there. If it crank it right up. Let it warm up. In the meantime, see that resistor? It's got little feet on it. They're pretty cool. They sort of strain relief. The little shoulders hit the board, and the pin goes through, and you just solder to the pin, and they sort of mechanically hold themselves in place. All I've got at the moment is just usual axial ones with the wire on the ends. So what I'll do is simulate that sort of setup. Some little ceramic standoffs, because you gotta get it off the board because it generates heat and it can cook the board, which isn't good. Coffee first. Oh, that's strong. 4 shots. Alright, so we know where the legs are on the old one. So we can sort of use that as our gauge for where to bend them. Sweet as. I'll pop these little buggers on there. Could just order the right resistor, but don't have to wait a week. There it is. Let's put that one in. Fold over the leads. A bit more mechanical support. Solder away. A little bit squeezy getting in here, but just try not to melt any insulation on any neighbouring wires while I'm there, which is something I see very often on amps worked on by others. Melted insulation, melted wiring left, right and centre from just a bad driver on the soldering iron. It's a bit like being back at school and you get your pen license. They should make soldering licenses. You're not allowed to solder, you get jail time if you solder without your soldering license. That'd be good. So, new bias resistors installed. Piss that one off. Ah, she's coming alive. Beauty. Better. Might leave that temp jacked up a bit for lead-free solder. Normally work on leaded stuff, so. So where are we? Put the ground connection back. Thread it through. Reroute that wiring where it was. It was just tucked under the board in the corner. So we'll do that again. going in? No. Here we go. Shut up, dogs. Is that a video dropping out? Looks like the screen's gone black. If anyone can let me know on your end what it looks like. Saying no drop frames, but I don't trust the internet to tell me the truth. Yeah, Jesse, it's going alright. Good to see you, man. Thanks for dropping by. Where are you from again? New York. Hectic. What time is it over there, mate? Must be what, 5 p.m. It's a long weekend here, so it's Monday, but everyone's got the day off. Queen's birthday. Like anyone gives a fuck. Anyway. I've just pinned some wires under the board when I've distracted myself with talking, so I have to dig them out. That's my the wired connections on top there that I disconnected. Wire them back up. Resistors a little bit flopping around. Want cable tight. Silicon it. Put a little packer under there and silicon it to it, something like that. Shows you how good our internet is in Australia. God, I can't even speak. Shows you how good our internet is in Australia, that you can see my stream problem free from New York, but I can't even watch it myself. It's probably my internet only wants to go one way. Yeah, man, we've got some third world internet here, eh? We just got, our government just sold everyone on this, this cheaper version of what they call the NBN here in Australia. and they're like, look, we don't have to spend as much as these crazy spendy people on the other side of government. We can do it cheap. And yeah, it's a pile of shit. But this government, they're called the Liberals, but they're like the opposite of what you guys in the US think of when you think of Liberals. They're like the Conservatives. Yeah. They rule on fear. So yeah, now we've got shit internet, and it's not going to get better anytime soon. They've overspent billions of dollars on it, and it ended up multiple billions of dollars more expensive than the one they were saying was too expensive, and it's half as good. Yay! Aren't we good? Anyway, got to deal with what we got. I do have a pretty shit level of it too. When I signed up for it, I didn't realise there was different tiers of speed. So I got a bit of a crappy one. I've got to upgrade it and just haven't had time to sit on the phone for 2 hours to some dickhead in India. So what's weather like in New York? Summer over there, isn't it? Your summer over there is probably like winter here, though. Alright, I think we're good. Let's put these 1Ks in. Screen grid stoppers. Before I have more coffee. Oh yeah, that's good shit. I probably shouldn't put 4 shots in 1 coffee. Wakes you up though. Alright, so cutting the legs short to mount on the tube socket. Valve socket. I call it tube socket. Now we've got an American here. Tube socket. Bend one end around. Make a little hook. Like that. Mount that on the socket. Go backwards. Just set them up for a dry run. And all the turrets are aligned different ways, which makes it fun. In the factory, there's no way of, I guess, lining them up. So to try and make it look sort of uniform, I'll just push the resistors around, bend the lead a little bit. Make that one go around. Shut up, dogs. It's not the dog's fault that they bark all day. They get bored. People buy a dog and just lock it up in their backyard and it just sits there bored all fucking day. Of course, you'd bark as well, wouldn't you? Put a compressor on the audio, so I think you can hear all the stuff in the background. Hopefully not the music too loud so I'll get a copyright strike. There were massive blobs of solder on top of the turrets before. There's no need to go overboard like that, Vox. Cool your jets. So I'll put a little bit less on this time. I've got a good mechanical connection. It's going through the fork turret, so we'll be right. Now I'm going to reconnect those 3.3K grid stoppers. Not going to hurt anything. Should be right, mate. Sweet as. Now, where do those wires go? They don't really fit. Squash the wire a little bit, they're tinned. I'll just clean the excess leaded solder off. Replace it with lead. Tastes better. Put a decent blob on there. And suck it off. What happens in the garage stays in the garage. Alright, pop them back in the turrets. Zoom in a bit there so you're not just staring at shit. Squash the lead a bit so it fits in the turret. Yeah, they wrap the resistor around the turret like 3 times, but then the cables are just sitting in them. Bend it a little bit because that turret's on an angle. One's done. Sweet. Check over it and we'll fire it up, see where the bias sits now. What up now? Might help if I solder them to the valve sockets too, eh? That would be pretty exciting. If we didn't. Alright, let's fire it up. Once I reconnect that ground anyway. Alright, so we've got a screw going through the chassis, then it goes through a lock washer, well, a star washer. Get in my belly. Then on goes the terminal. You bastard. Doesn't make for very good viewing. Breaking my wrist inside a chassis. Then we have a split washer. Pop that in. Then we've got the nut. And pop that on. I'll just use the old one for now, but before I send it back, I'll replace it with a nylock nut. Tighten that up. Want a good ground, or all sorts of shit will go wrong. Give it some signal just to check that everything's sounding alright. At least passing signal. Plug in this spricker. Set the bias to the hot one, and we'll measure that. Popped up to 70 watts, back down to 60, back down to 50. That's about right for the inrush current for the heaters. Click the voltage mode. We'll check this cathode voltage, eh? We'll do a quick calculation. There's the signal. Alright, so where are we sitting? We've got 10.9, say 11 volts. On the cathode, 11 volts on the cathode. Remember that for me, would you? 317 on the plates. 317, 317, 317, 318. We'll say 318 to be safe. And 11 on the cathode. So let's chuck that into Rob Robinette's fancy website. 18, so minus 11, so 307 volts, plate to cathode. EL84, 12 watt. We've got 4 tubes that share that resistor. Got 11 volt drop across it, and it's 100 ohm. Hang on. Let's do that. So we'll test it on the warm first. I'll pop that over because I've got the 2 resistors in parallel there. So I just want to test the change of that one resistor. So we'll have to take our measurements again. Gave you a bum steer. Alright, so let's try that again. Cathode's sitting at 13 volts. And the plate's at 333. So 13 and 333. 331 over there. Oh, no, it's dropped down. 332. Must have still been warming up a bit. 13.3 and 332. Let's go over to this. So we got what did we say? 332 minus 13.3. 318.7 plate to cathode. I don't do math on video because I always fuck it up. We got 4 resistors and 13.3 volts. Cathode is just 100 ohm. So that's sitting at 88. So that's comfy. Let's turn that off. Don't worry about standby. Standby's for wusses. And now we'll just double check the resistance when we click it over. So I'm clicking it to hot bias now, which used to be 50 ohms, or 53. And now it is 59. I would say 60 ohm, 59.8, 60 ohm. So it's between 60 and 100 now. So I reckon 60 is still going to be pretty hot. It's probably going to be like 115% or something. Want to put a bet on that? Oh, yes. So yeah, let's test that out. Ten 10.7, rising slowly as it warms up. 10.9, 11, settling out at 11 volts. 11 volts, and the plate is 319. 319. So that's 308 plate cathode, 11 volts there. Oh, hang on, calculate. 11 volts there, 60 ohms. So So we're at 117. Ah, it's 2% off my guess. Oh well. 117 is pretty hot. It's a lot less than it was, and this guy's had this amp since new and hasn't had a real issue with it. So I reckon we're done. I'll run it in. You probably see the bias will cool down a bit as the tubes bed in, wear in. Still sitting at 11, so it's not moving much. That's ground. Yeah. $305. Instead of subtracting, I'll just measure the plate to cathode. 305, drifting a little bit, but 305 volts, say 306 to be safe. Let's just double check that. 306 volts and 11 volts on the cathode and 60 ohms, so 116. Yeah, it's warm, but it's not Vox warm. So oh, hang on, that's triode. So yeah, 110. So we're on 110%. So yeah, it's not 116. 110%, which is pretty warm, but like I say, it's not warm for a Vox. The old tubes you can see were absolutely cooking. The writing had burned off, and you might have seen me post about that on the page. Like, the writing's completely gone. You can just see little shadows of where it used to be, but she's gone. You can see around the ridge the mica washer in there. There's like a mica spacer, and around the vents in the anode, you can see where basically the plating on the cathode is boiled off and condensed on the glass, and that happens when they're running real hot, or that can happen when your heater voltage is too high. Let's check the heater voltage. Set it to AC. It's coming in here. 6 volts, bang on 6, which is a little bit low if anything. .9, it's getting less and less as you go along the daisy chain, along the wires. I think they're good. There's no hint of red plating, and with those higher value screen grids, I think we're in the clear. So yeah, I might get this one back together, which is going to be pretty boring to watch, and piss it off. Give the cabinet a clean, give the front panel a bit of a clean, check the pots aren't scratchy, that kind of thing, check everything works right, and then give it a tonal test and see that it's got all the rocks and the rolls that it should have, and send it back. We'll get on to the next one. Got a few others today, and if you want to keep me company while the missus is at netball and I've got nothing better to do, come on back. I'll see ya then.